So let's turn our attention now to the idea of section 2.2, which is actually our very first section here. We're going to be trying to understand, again, one of the foundational ideas of all of calculus. If anyone ever asks you the question, what is calculus all about? Your answer should automatically and every time be limits. So this is going to be crucial. Everything that we talked about in the last video and all of those interesting calculus questions we're going to try to address this semester are all tied up in really understanding what this new thing is. So let's take a look at it here. What we're going to be giving in this section is a very intuitive approach to the idea of a limit, which means I'm going to be kind of giving you like a hand-wavy, sort of loose idea of what a limit is, and we'll be able to narrow down and drill down on more of the specifics in later sections. Let's take a look here at this kind of intuitive, loose, not perfectly correct definition, but something to help get the ball rolling. Okay, it sounds a little bit confusing at first, but don't be too intimidated. Here's what we have. Suppose f of x, so a function, is defined when x is near a number a. Okay, so I can immediately start to imagine something like an x and a y-axis, and I'm going to have a function, and there's a number a. So maybe near the number a, the function exists. Notice, this means that f is defined on some open interval that contains a, but maybe not at a itself. So it's totally possible that maybe the function doesn't exist at the value of a. Maybe there's like a hole in the graph or a vertical asymptote. But kind of around a, we can see that there is a function, right? There's parts of that function there. Well, then what we're going to go ahead and do is we're going to write out this set of symbols. The symbol for limit is this lim, but it has to have these other pieces with it. When you have a limit, you have to take the limit of a function. It's something that you do to a function. And it also has this notation here where we have x and then an arrow and then a, which is going to represent a number. And we'll say that this is equal to some other value. Ultimately, we would read this as the limit of f of x as x approaches a is equal to L. All right, that still doesn't tell me at all what that means, but that's what this part down here says. We would make this claim and say that these two things are equal if we can make the values of f of x, that is, if we can make the y values of our function arbitrarily close to L by taking x to be sufficiently close to a. Okay, if you're anything like me when I was a student, I've already given up on that definition. That's unbelievably confusing. Don't be too alarmed by that. We'll actually try to break down in this video a little bit more about what this means and how it corresponds to some different pictures. Let's take a look here at some of the notation to try to, again, just break down what it means before we further look into this last sentence. So we have this set of symbols here, and we really need to make sure we understand what all of this is saying. So I'm going to go ahead and mark up this picture here a little bit. Keep in mind that this lim is, again, really just going to be short for the word limit. And a limit is something that I always do to a function. So I have to be able to state, after I write the word limit, what function I'm doing the limit to. So I'll write over here that this is the function that we are taking the limit of. Okay. Now I have these other symbols down here, which is the x and the arrow and the a. X right here is really just standing for the variable that's occurring inside my function. So if this was f of t, and I had t's inside my formula, then this would be a t. This variable here should match that variable there. But this value of a is very important. Most of the time when we look in specific questions, we won't have a value like a letter a, but instead, kind of like down here on example 4, you'll see that I'll have a number in place of here. And this value is going to be what our variable is approaching. Okay. Now again, that still doesn't necessarily address the issue of what the heck is this asking me to do? But if I can at least understand all the different pieces, then when I look at a very specific example, I think we can break down exactly what this is asking of me. So let's take a look down here at a very simple example to try to get a sense of what's going on. Okay, so example number 4. What would we expect the value of this to be? So notice here I have a limit applied to the function x squared when x is moving towards or approaching 2. Okay, that's a mouthful. So limit of x squared as x approaches 2. Now this is supposed to be equal to something. It's going to actually be equal to a specific y value. But let's take a look at how we would determine this. Here's the idea, the base idea. What we can start to see is that the graph of x squared looks something like the picture that I have below. Here's a nice easy picture of our function. I'll even write it down over here. This is f of x equals x squared. And our goal right now is, with a limit, to imagine this function as kind of like a path. And the limit says, why don't we jump on the path, and let's slowly start to move towards the x value of 2. Let's move so we're above the x value of 2. So if I started over here on the path, I would have to kind of walk this way along it in order to get closer to being above the x value of 2. If I was over here, I would have to move this way along the path to get above 2. And our goal is to watch where the path is leading us. So let's take a look here. Notice I'm going to start by taking a look at the table that I have down below. And I'm going to start by looking at what happens when I have the value 1 plugged in. And I'm going to go all the way over to think about what happens when I have the value of 3 plugged in. Okay, so let's take a look at what we have here. If I was to go ahead and plug the value of 1 into my function to figure out where I'm at, it's very, very easy to see that I'm at the value of 1. Now, I'm going to go ahead and I'm slowly going to start to move towards the x value of 2 this way. I'm going to start to imagine sliding over. And so I'm going to imagine, well, what would happen if I was at the value of 1.5? Well, if I was at the value of 1.5, I'd be somewhere like up here on the function now. And so can I easily figure out what y-coordinate I would be sitting at? Well, sure, right? I mean, I would just need to go ahead and take 1.5 and plug it into this function. If you have a calculator, I'd actually ask you to go ahead and do this just to confirm for yourself. If I go ahead and I plug 1.5 in for x in this x squared formula, I should get a value back like 2.25. Well, what if I moved even closer to 2, right? This goal of the limit is to say move super close to 2. So what if I stepped even closer to the value of 1.9? Well, if I plug 1.9 here in for x, I get, well, you could double check yourself, but I get something like 3.61. I'm actually going to do each of these values. I'm going to continually step closer to 2. Now, I'm going to go ahead, and if I plug in 1.99, I'm going to get 3.9601. I'm getting even closer to the x value of 2 by going to 1.999. And if I plug that in, I'm going to get 3.9960001. Notice again, what I'm doing is I'm moving towards the x value of 2, and my goal is to try to figure out where does it look like the path is leading me. Now this is a difficult question to separate from where is the function. Notice my goal here is not to plug in the number 2, or I would have just done that from the start. My goal is instead to kind of imagine walking along the path and thinking about where the path is ultimately leading me. Well, let's take a look here as we come from the other end. What if I was to imagine coming in this direction? So let's start at 3 and move backwards towards 2. If I plugged 3 in, obviously I get 9 as my y-coordinate up here. If I plug in 2.5, you could confirm you get the value 6.25. Well, if I got to get even closer to 2, maybe I go to like 2.1. And if I plug that in, I get 4.41. If I plug in 2.01, notice I'm getting even closer to 2. I'm going to get 4.0401. And if I plugged in 2.001, I'm getting really close. I get a value of 4.004001. And so I can ask the question, let's look at those y values and start to see, where does it look like they're going? It almost looks like these black y values are squeezing in on some value. And what would you guess the value is? Well, yeah, you might not be too surprised to guess that it looks like I'm being pushed towards the value of 4. In fact, in the picture, that's exactly where we would end up, right? It looks like I'm kind of being led to this blue dot. If I walk the path this way, or if I walk the path that way, I'm getting walked to the y value of 4. And so what we would say is that based on these results, we would say that the limit as x approaches 2 of x squared is 4. Notice the answer to a limit is always the y-coordinate that the path is leading you towards. This is a very important thing to separate from the y-coordinate of the function. But we'll see more about how this works in the videos to come.